If you're building AI agents, you're probably frustrated with AI agent evaluation. Most tests only check if your agent gets the right answer, but what if it takes 10x longer than it should? Or what if it burns through your API budget, trying wrong tools? In production, you need agents that work both reliably and efficiently. And today, I'm showing you a breakthrough framework that finally measures what actually matters. Large language models are getting smarter. They're moving beyond just writing text to actually using real tools through MCPs. But here is the problem. Current tests only care if they get the right answer, completely missing how well they actually work with the tools. We are just ignoring crucial things like process quality and error recovery. So we have no idea what these models can really do. That's where MCP-RADAR comes in. It's a completely new 5-part evaluation system that actually looks at the whole picture. It doesn't only check for the accuracy of the end result, but also pays attention on which tools were selected, or how long it was doing right until the first error hit in, as well as the compute resource efficiency and the overall speed of the response. Each measurement can be tracked and displayed using radar charts to display complete performance profiles. The benchmark tests 300 tasks across 3 areas: software engineering, math problems, and general problem solving, using 42 real-world MCPs. This goes way beyond single measurements, giving us deeper insights into what models are actually good at and where they struggle. Now here is the practical part. Whether you're using Claude, GPT, or any other model as your agent's brain, you can apply these exact metrics to evaluate your agents. Although the research was done on major LLMs, the framework itself works for any tool using AI system. And here is how to implement each of the dimensions. Result accuracy. Simply count successful completions divided by total tasks. A task succeeds when the final answer matches the expected result. Tool selection accuracy. Track every tool call as correct or incorrect and calculate as the amount of correct tool calls divided by total tool calls. First error position. When your agent fails, identify on which step the error occurred first, and then take an average. Higher scores means error happened later, which is better. Computational resource efficiency. Count tokens used per task. Lower usage while maintaining accuracy indicates better efficiency. Response time efficiency. Measure end-to-end time from input to response. This captures both model speed and tool execution time. With these metrics in hand, let's see what the researchers discovered when they put today's top models to the test. Because these same models are likely powering your agents right now. Let's see the actual data and start from tool selection accuracy and error resilience. As you see, Claude 3.7 Sonnet absolutely dominates in both of these, leading with 75% of tool selection rate and 81% of error recovery, which is great. After that, we have Gemini 2.5 Pro, which follows closely in both areas. And way after both of them, we have GPT-4o, which is definitely the worst possible option. That's why if your scenario is complex and dynamic, you definitely need to use Claude 3.7 Sonnet in order to achieve the best performance. At the same time, if looking at token efficiency and the response time, both are better when these numbers are lower. Basically, you can see the amount of tokens used in average and the amount of milliseconds it takes to respond with the final answer. We can see that in both of cases, DeepSeek V3 is a clear winner, taking just under 2 seconds to respond with the end answer. Considering that it is also a reasoning model, it is definitely a great result. And after, we have GPT-4o Mini and Llama 3 that follow pretty close, but still beyond. And as you can see, we also don't see neither Claude nor Gemini here, because both of them sacrifice their speed and efficiency for accuracy, ranking amongst the slowest and most resource-heavy. The bottom line. There is no perfect agent model yet, but now you know exactly how to do proper AI agent evaluation. Use this approach to evaluate your agents properly. Don't just check if they get the right answer. Measure how they get there. The framework and all the research data are completely open source in this paper. You can see the full methodology, all the test results, and even the code to implement it yourself. This is exactly what you need to start properly evaluating your agents today.